Hello global supply chainers and welcome to the first Hangout event in SC1x. And I hope you have enjoyed the course so far. My name is Ahmad Hemmati and today we have Dr. Chris Kaplis, the Executive Director of MIT Center for Transportation and Logistics. And Chris is going to talk about forecasting today. So Chris, have you checked the weather forecast today?
The weather forecast, yeah, the weather forecast was pretty crazy. What it's doing now. So right here in Boston, we're supposed to get, what, 8 to 12 inches or more of snow. And so I don't know if we had the camera going. Arthur, did you have the camera going to show the snow before?
There earlier, yep.
Yeah, it's pretty crazy. So we are the only people here at MIT. MIT is officially closed, but we didn't want to miss out on the Hangout.
Yeah, great. So I think you have done a lot of project, in forecasting for big companies, and I want you to share your experience.
Sure. So most of my experience in forecasting has been with projects. So forecasting is not my research area, but we do a lot of projects in this area. So let me talk about two that were kind of interest and fit into some of the things you've been doing, especially the last week, because a lot of companies will come to us and they want us to develop better forecasting models. Let me give you one that you'll see again after the midterm. I believe it'll be in week 4, 5, 6, 7 when we talk about single period models. We did a project, a company called Reebok, now owned by Adidas. He had the contract to make football jerseys, American football, right? The real football with helmets and everything, not soccer, not that kids game. But they had the exclusive license to sell jerseys. And so they came to us with a project because they said, our forecasts for predicting how many jerseys to make of each team and of each player, because each player has a unique number and name and all that. They wanted to figure out, how can I forecast that? Because they were being manufactured halfway across the world, in the Philippines, I believe, at that point. And so they had to figure it out 6 months ahead before the season, how many to make of each jersey. And so we went in, 2 students worked on this, and they came up with a couple conclusions. One is the team that ends up winning the Super Bowl, that does the best, sells the most jerseys. And the second is, on the team, the player who did the best tends to sell the most jerseys. But they came back with the idea and told Reebok, if we could predict which team, 6 months ahead of time, which team could win the Super Bowl and which player would do the best, we would not be making shirts. We'd be betting in Las Vegas. And so the whole idea of that was, there are some things you can't predict, where forecasting doesn't really help you too much. And I'm not going to tell you the second half of that story, because you'll learn about it in week 7 and what we did instead. So a company came and said, we want you to improve our forecasting, and instead we gave them a better way to model their inventory. And so you'll see that in week 7. Excuse me. But let me give you some other examples. We did a project with a large water bottler, and several of their employees from their company are taking the course now, actually. So I'll keep their name out of it. But what they had an issue is, they wanted to get the demand of the bottled water sold to all the different stores. And they went from the manufacturing plant straight to the distribution centers of the customers. And these range from large mass merchandisers like the Walmarts, Costco, Kroger's, down to small stores, 7-Eleven and whatever. So they all had very different demands. And so we wanted to figure out how to forecast, because water takes up a lot of space and it's not a high margin item. So you want to keep it moving very quickly. And so we looked at this, develop a forecasting model for them. And 2 things came out. One is some of the mistakes that we made as a team. We were looking at the order data. And we looked at the order data, and as you can imagine, orders come in very sporadically. And so they might come in, someone might order water once a week, some every 2 weeks, once a month. So our demand looked very spiky, right? And so what we had to do was transform that into the real demand, because were the orders, and that was based on a lot of different things. They had a full truck minimum order quantity discount, right? So that made that demand very spiky. So we had to smooth that out to try to get to the real demand. That's one thing that we learned. So when you're doing your demand modeling, make sure you're actually forecasting the demand. You're looking at getting actual demand as best as you can, sales. The other thing is we built a causal model for this, and one of the big drivers was temperature. And so as you can guess, as the temperature goes up, generally more water gets consumed. But we found it wasn't uniform. You can't just put it into a regression because an extra 10 degrees in temperature in, say, Texas is not the same as an extra 10 degrees in Maine, which is a northern state in the United States where it's colder. And so we normalized that and looked at the temperature based on the typical temperature that month. But then if you looked at that, even that didn't make sense, even though it made the model look better, because you don't know the temperature far enough in advance when you have to make the forecast. So another lesson that the team learned.
Here.
Yeah.
Sorry, why didn't you divide the states? You know, the forecast for Texas and forecast for other places.
We did that for, and they had different behaviors. But a lot of times a single plant will serve multiple states. And so generally, anyone who's been in any kind of bottling soda, beer, you're not going to ship the stuff too far because it's very expensive, right? And so they generally had short distances. But for example, some of the plants in California would serve very different climates. But you could break that down. So those are two lessons that we had from there. And there's other examples, but most of the projects we had looked at how you can usually use causal models to try to understand how the demand will change.
A basic question: when you get a project regarding forecasting the demands and something like that, what's the first step you do? So to me, graphing the data is, plotting the data you have is the first step. What do you think?
Yeah, I think there's so many good data visualization tools out there, and so getting the data and understanding what's there. And we talk about this in some later courses. If anyone's taking SC4x, just getting the big data and taking the averages, you don't want to do that. You actually want to look at a time series. You want to look at it over time, and because you want to be able to explain certain things. One of the problems that we've had in forecasting is that people take the history and start regressing on it, right? And they assume it's going to go forward. But what you have to do is you have to strip out certain things. You have to strip out past promotions. Promotions are very common in consumer packaged goods. You have to strip out any pricing changes. So history is not pure history you can repeat. You have to clean it first and make it so you get down to the core things that you think are repeatable. But yeah, looking at the data in the past is always the first step.
You bring it a very good topic, the kind of the data cleaning maybe, and the noise in the data. So do you suggest to data cleaning before start the?
Oh yeah, it's such a
maybe
pain.
SC4 topic, but
we talked about it. No, but it's an important thing, and I think we talked about most of the key things in SC0, and hopefully everyone's taken SC0, where you have a distribution of data. You look at central tendency, right, and the mean, the mode, the median. You look at dispersion or spread. That's great, but you have to look a little deeper, and you have to make sure that outliers aren't weighing your metrics. And so what I always like to do is, one, graph it out. I like to use Tableau. It's a great tool. There's probably a free version out there. And in fact, that's what I use when I talk about forecasting. I believe I showed some scatter plots to show seasonality. It's a great tool to dive in, but I also like to go top 10, bottom 10, because typically what happens is if the variability metric and the mean is very biased with extreme values. So if you're looking at demand data, you're typically going to be right skewed, right? Because you can't usually have negative demand. So one outlier way out here is going to influence a lot of things. And so you need to make sure, and that's why I like to look top 10, bottom 10. It's a good way of identifying those outliers, because you don't want those to be dictating your demand forecast.
But maybe that outlier is because of a promotion or something like that.
Absolutely. So there's a difference between cleaning, identifying outliers, and getting rid of them. The cardinal rule of data cleaning is never get rid of data. You just you never delete it. You just keep it separate. But I always look at the outliers. The outliers, it's like looking at the comments or the footnotes in a financial statement. That's where all the important information is. And so that helps you a lot.
And I believe it's a very good point to to not delete anything, just to check what's going on, what this data has been happening or why to the the reason of that outlier. So one other things that I want to ask you is sampling. So, when you want to regress, you need some data to sample, another data for tuning the parameters, and one to test actually. So how do you select the?
Yeah, and you have as much of an answer to this as I do. I think it's more of an art form than actually. There's actual science. If you're looking at seasonality, you want to test over 2 periods, 2 complete cycles, right? And so if you're looking at annual seasonality, you need 2 years of data. The problem is you might be able to get 5 years of data, but the conditions under which those years, 2, 3, 4 back, might be totally different. So a lot of times you might have 5 years or 3 years worth of data, but the prices changed, the competition changed, the products have changed. A lot of times new products come in and go. So you might not have, it's a luxury to have clean data for 2, 3, 4 years. You generally have to live with what you got. That's the real scary thing. So you might come in and you're making a forecast, and you think there's seasonality, but you only have 18 months of data. What do? You can't just throw up your hands and say, I'll wait for 6 months to get more data and then I'll come up with my model. So part of it is if you don't have perfect data, do best with what you got, but then caveat it, make sure you know that, hey, here's the assumptions I made, I've got a weakness here, I didn't have full 2 years, whatever, but just go in knowing and let people know what shortcuts you had to make because of the data. Ideally, you should have multiple periods of the initial data, then training data and validation, but it's so rare in practice. But if you go, for most of the places you're working, there probably already is a forecasting system going on. And so what I typically tell students when they go into a job, if they're going into a forecasting position, to ask people what's being done, because any company worth their salt's going to have a high-powered statistical forecasting tool. It might be part of their ERP, it might be part of SAP or Connexus or Oracle, it might be a standalone one, but it usually has a lot of bells and whistles. And I guarantee when you go in there and start asking the people who run these forecasts, they don't know what's going on in the model. So you got to be aware of the black box. And so one thing you should always do is try to understand what the parameters are. A lot of companies now, they'll put the data in, they'll come out with multiple forecasts, and they'll kind of do a blended. And so they might do a blended of exponential smoothing, of some other techniques, and then it kind of blends and picks the best one out of those. So all that I caution people to do is just make sure you know what's going on and don't treat it like a black box. Also to look at sometimes the parameters that are set, and this is really big in inventory too. So we'll get into that a little later, but ERP systems always have inputs, a reorder point typically for all SKUs, all SKUs. And typically the person who set that is long gone. They've been gone for 10 years and no one revisits them. And so it's another thing, whenever you inherit a system, whether it's forecasting, inventory management, warehouse management, transportation management, check the parameters. Just understand how decisions are being made, because chances are it's the ghost of someone who's been gone for 5 years who set those parameters and they were never revisited.
Again, regarding regression, you always say that we should avoid overfitting. Why?
Yeah, so overfitting, because regression's awesome, and students always try to drive to that R squared. They want the highest R squared possible. But you have to think back about what that is doing. That's just fitting back to history. History won't repeat itself. Whenever we do any of these forecasting, we're assuming that the exact values from last year won't occur, but they come from the same distribution. That's what we're really saying. We're saying, okay, here's the distribution with this mean and this standard deviation of whatever form. We think that's going to repeat. And so if you map exactly overfit to the exact outcome, it's like mapping to a sample, not forecasting the distribution. And so overfitting tends to give you false comfort that you have a really accurate model, and this precision is not the same thing as accuracy. So it tends to lead for more fragile kind of forecasts. And I think in SC0x, I give that very simple example of the 4 dots, 4 points, and you can get an R square of 1, and it's ridiculous. So you have to think about what's the purpose of the model. The purpose of a forecast is to give guidance. It sets some kind of goal, hopefully a range that you want to plan your inventory, manufacturing, distribution, and other things too. It's not looking for the perfect number because it's based on assumptions and all this anyway. So you want to make something usable. Long answer to a short question, sorry.
No problem. You also said about the parameters. So how should we define the parameters like alpha, beta? We had a very long discussion, discussion forum regarding this. It's
an art form. They're rules of thumb. And so think about what the alphas, the betas, and the gammas all do. And they all do the same thing, which I think this is why I start whenever I teach forecasting, I start with the naive model and the cumulative model because they do the exact same thing. It's how much information do I want to, or how much weight do I want to put on the new information versus the old information. And so the alpha is just looking at for how much do I take that latest forecast or that latest outcome rather versus the forecasted numbers that I've had before, and that wraps up all the previous time. So it's a balance of the new and the old. And so I think I gave numbers for what they are, the standard rules of thumb, like a 0.1 and a 0.25 or something for beta. I don't remember the gammas. It's an art form. I think it's trial and error. Some people have very strong opinions on them, but generally what some students do is they take past history and they run smoothing for it as if they're going through, and they do it trying to minimize their MAPE or their root mean square error by adjusting that alpha. That's the same thing as overfitting. So you can find something to make it fit exactly, but that doesn't mean it's going to be good for you going forward. Does that make sense? Yeah, it's the same thing.
I think so. So, and I want to make something clear here. You mentioned the method that we have covered in SC1 for forecasting. I want to say that these are not the only methods that are out there for forecasting. They are the basics. They are the classic methods for forecasting. There are very complex methods out there, like machine learning, SVM. Some of them are covered in SC4. And but the others like ARIMA is not covered, but you have enough information in SC1. You have the basic concepts for dealing with ARIMA, and at the end of the day, you are going to use the softwares for your forecasting, and then it's just a click to get the results. But all you need is to learn the concepts.
Yeah.
That I think it's well covered by you.
ARIMA is one that people are starting to use or have been using for a number of years, but there have been studies. I go back and forth. There have been a lot of studies that these very, very precise, very complicated forecasting methods don't yield any better results than a simple exponential smoothing model. Different companies have different outcomes. It really depends a lot on how new your products are, right? So when we talk about new product introductions, those are the hardest ones because you're kind of making guesses. And in SC3x, we'll talk about Bass diffusion curves. We used to teach it in one, but I moved it out. It was a little too much. But the whole idea of fitting to a curve. And so there's all these different techniques, and different industries have very different ways of doing their forecast. Let me give you another example. We did a project with Procter & Gamble, and they had, their challenge was they're selling diapers to some of the retailers, obviously. Pampers is their brand. And one of the challenges they have is most of these are sold under promotion. So a Target or a Walmart or one of these retailers for 1 week will give a certain promotion to a line of SKUs. And so this happens every week for different SKUs in different parts of the country. And so what they wanted to do is they asked us to figure a way to improve their performance under these promotions. Because as you can imagine, what can happen is if you lower the price, the demand goes up a lot, as you expect, right? And so you've got to preload a bunch of the product to the DCs of the customers ahead of time. So the question is, how much do I load forward? Do I just wait and do what they order, or do I pre-stock some additional ones? Because you don't want to run out early, and you don't want to have too much left over at the end of the promotion period if it lasts a week. So we came up with a bunch of different ways to try to figure out how much to order they should place in advance. but we also developed a pretty interesting forecasting model that it was a causal model, and it looked at the main driver was the drop in price. So you look at the base price minus the promotion price, right? And we did that in a polynomial. So we'd have a beta plus beta 1 times base price minus promotion price, right? Plus beta 2 times the same thing, base price minus promotion price squared, right? Because we figured it had a tailing effect. And it worked very well. And then, in fact, my colleague, Dr. Francisco Joffre, added to this and added in a period term using sines and cosines that looked at every 7 days, every 21 days, there was a cycle, because it's 7 days in the week. It kind of made sense. And so adding that in made it even more interesting because it captured some of the effects of weekends versus weekdays. And then the final thing we did, since we have this model now where demand is a function of price, right? D is a function of P, the price, we could find what the revenue is going to be, which is just price times the demand, right? That's the expected revenue. Demand's a function of price. So the question is, what P should I pick? What is my optimal price to maximize my revenue? And so you can actually figure this out. And what Francisco did, Dr. Joffre, he went back and tried to determine what the optimal price, discount price should be to maximize revenues under promotions for a bunch of these different lines, and found that in, I want to say 80% of the cases, P&G was within 5%. They were very close. And so it did two things. One, it shows that you can come up to an optimal revenue. It's a neat approach for discount pricing, but also it shows the strength and the power of some of these people who've been doing it a long time. They tend to know what they're doing. So it was kind of reinforcing. But that's another way how forecasting using a causal model with a nonlinear term actually could be used to help the forecasting as well as the inventory modeling.
Yeah. When you say your forecasting model worked well, what's your measure? Actually, they're asking us that, we have different index like
Sure.
RMSE, MAPE, and those things. Which one is the best measure for?
So MAPE is common, and so we see that the most common when people compare. But you'll see that the root mean square error, the RMSE, is going to be widely used in forecasting. Now, in inventory management. Now, when you're looking this week, we introduced EOQ. We're assuming deterministic world, so we're assuming your forecasts are perfect and demand is uniform and deterministic. Then following weeks, we're going to loosen that assumption, and so when we bring in variability of demand, what we're really doing is bringing variability of forecast error. And so the forecast error, measured as a root mean square error over the lead time, this will make sense to you in about 2 weeks, is what really drives your inventory. So that's the connection where inventory comes in. So to measure it, MAPE is most commonly used, but the root mean square error really drives the inventory.
Great. One of the challenges in forecasting is the data availability. So
is what?
The availability of the data.
Oh, yeah,
so
sure.
Most of the time, you don't have enough data.
Yeah.
What do you usually do in this case?
Make it up. No, I'm kidding. So you can actually simulate some data, but you got to go with what you got. And so I've had, I've run regressions on data sets of less than 32 sample, piece of information. So you do with what you can, but just don't assume that it's going to be perfect. You just got to say, okay, it's only based on, just list your assumptions and make sure people are aware of how strong or weak your base is. But with data, that's usually the hardest part. And it's not, data is there, it's never the right data, right? And so, we're swimming in data is the common phrase because we're getting it from sensors. The data collection is very strong. We're swimming in it, but the data we want is usually in a different pool, right? It's not where we want it. So, for example, I do a lot of forecasting of transportation rates and things like that. And the way the data you want doesn't exist in one place. And so the rates might be in the ERP, the TMS might contain some of the origin destination, and then the warehouse management or the yard management system might include the dwell time, the wait time. And so one of the challenges you'll find for any forecasting model that is a little more diverse is pulling from disparate data sources. And that's why in SC4x, we teach you how to use databases and how to bring things together in structured format, because that's the only way you can do it. We wean you off of spreadsheets slowly because you need that for production. And so the challenge I have is not just that the data isn't there. Sometimes the data that is there is corrupt or suspicious or not quite what you want, or it's coming from multiple sources and it's hard to find.
Great.
Yep.
So before going to the next question, we may have a breakout room. So
Yeah. So what the question we agreed? Do you want me to read it?
Yep.
Yeah. So forecasting is great. The mathematics, that's kind of what we drove into you, so you know how to use the mathematical techniques. So what I want you guys to do in your breakout, talk about how you would incorporate some of these non-quantitative things that have come up, some of these political actions or political situations that have come up, whether it's elections or otherwise. Think of Brexit, think of the election of President Trump, think of the elections coming up in France and the Netherlands coming up soon. Situations happening in Turkey. So all of these things, how would you incorporate these things into your forecasting? So I want you to discuss that because it's having major implications. There was a funny anecdote in Britain. There was a huge shortage of Marmite earlier in the fall. And it's mainly because Unilever, who is the major, do you know what Marmite have you had?
No.
It's disgusting, right? It's this disgusting food that only British people like. But there's a shortage because Unilever couldn't bring it in because there was a bunch of situations. So you have it does affect things. So I want you to take, 10, 15 minutes?
Yep.
Okay, 15 minutes. So that brings us back at quarter after. Come back and then text in or use the chat.
Yeah, and I want the CTAs, if they are there, to moderate the rooms and bring the summary of the discussion to the lobby, so we can later discuss on that.
All right.
So
see you in 15 minutes. Talk about how you incorporate these non-quantitative factors into your forecasting.
see you.